What's up, guys? Welcome back from spring break. Hope everyone is staying well and staying healthy and all that good stuff. But we are going to move forward today and move on to chapter 9. All right, so chapter 8 we just finished, which was graphing quadratic functions. And you guys took a benchmark on it and all that stuff. And frankly, I just don't love the test online for chapter 8. So we're just going to kind of move on. We're going to take your grades from that and just kind of move on. So we're going to move to chapter 9, which is solving quadratic equations or functions. All right. So what you should be noticing is we are still looking at the same types of problems that we've been working with for 2 chapters now, really. All right. So chapter 8 and chapter 7 that we just kind of finished up, everything we've been looking at is a quadratic function. All right. So what we're going to do is we're going to look at different ways that we can solve quadratic equations. So what does solving mean? All right. Well, what we did when we graphed in chapter 8 was we just kind of graphed it. We never looked at like where do the lines cross the x-axis. All right. Because if we did look at that, that would tell us the solutions of these quadratic equations. All right. So like I'm going to show you real quick. We're going to skip 9.1 too, because what 9.1 is, it's solving quadratic equations by graphing, which you guys already know how to graph these quadratic equations in multiple different ways. All right, so I'm going to skip this. But I'm going to show you it really fast of like, what are we talking about here? Okay, so it says like a quadratic equation is a nonlinear equation that can be written in the standard form ax squared plus bx plus c equals 0, where a is not 0. So basically just saying like this number in front of x squared is not 0. All right. And if we read this, it says it in chapter 7, you technically solved quadratic equations by factoring. When we factored in chapter 7, we found like what numbers could we plug in for x that would make these expressions equal 0. Hopefully you remember me saying that, because we're doing the same type of thing, but in different ways. All right. So again, in chapter 7, you solved quadratic equations by factoring. You can also solve quadratic equations in standard form by finding the x-intercepts of the graph of the related function. So they're just saying that if we graphed this, right, and we found where it crossed the x-axis, which is essentially right here at -3, and right here at +1, we could find the solutions of this equation or this function, okay? If we remember, I'm going to do this real quick. If we remember in chapter 7, if I gave you guys this function right here, we would go like this. We'd put -3 on the top. We'd put 2 on the bottom. We'd try to figure out what numbers multiply to equal -3 and add to 2, right? We would try and figure that out. Well, the numbers would be 3 and -1. And we'd go like this. We'd go x plus 3 and x minus 1 equal 0, right? And then we'd say, what then makes this expression equal 0, and what makes this expression equal 0? -3 would make the first one equal 0, or +1, right? So what they're just showing you here is if we actually graph this function now, right, and we found where the lines cross the x-axis, the x-intercepts are the solutions to this function, okay? So that's basically what they're showing you in 9.1, which we're, like I said, we're going to kind of skip it because you already know, number one, we could factor to solve, right? And then you already know how to graph, okay? So we're just going to kind of skip 9.1. All right, we're going to skip 9.1. We're going to move on to 9.2. All right, so 9.2 involves using square roots. All right, really important about using square roots. The fact that square roots kind of have like two answers. Like if you took the square root of 81, for example, well, 9 and technically -9 work for taking the square root of 81, because 9 times 9 is 81 and -9 times -9 is 81, for example. All right, so that's really important for 9.2, is the fact that when we take a square root, there are two solutions. All right, so here's the lesson. Again, like I've always said, like kind of get a notebook out and maybe take notes while I talk, and try some of the on your own problems throughout the lesson. Pause it if you need to. All right. So I'm going to just kind of fly through. So here we go. So 9.2, it says in section 6.1, you studied properties of square roots. Here you will use square roots to solve quadratic equations of the form ax squared plus c equals 0. All right. So what that's essentially saying is we can use square roots to solve functions, quadratic functions, but we can only use this method if it's in a specific form. Okay. If it's in a specific form, which is ax squared plus c equals 0. All right. Then underneath it says, here's a key idea. Solving quadratic equations using square roots consists of, you can solve x squared equals some number, d, they're using as a variable, by taking the square root of each side. All right. So what it's saying is when this number, so like, I'm gonna write a quick example. If it said x squared, I'm gonna use the same example. X squared equals 81. It's saying when d, or this number, 81, is greater than 0, this equation is going to have two real solutions, the positive and negative square root of 81, okay? Which would be, again, the solutions here would be 9 or negative 9, all right? It's saying that here, it's saying here, in the second bullet point, that when d is equal to 0, right? So it's like x squared equals 0. Well, there's only one answer. 0, there's no negative 0. It doesn't make sense, right? But then it's saying this. When d is less than 0 in the third bullet point, there's no solution. So example, if we solve this thing, right? And we end up with this. X squared equals negative 9, for example. Negative 9. There's no solution, okay? Because taking the square root of a negative number doesn't make sense. All right. When we square something, I've said this in class, when we square something, it's always positive, which tells us that it doesn't make sense for us to have a negative number and take the square root of it. All right. So here's the deal. Here's the first example. If we want to solve this equation, right? Guys, it's the exact same thing as solving a normal equation, but we want to isolate, instead of just isolating x, we want to isolate x squared. But in the end, we want to take the square root. All right. So that's essentially it. It's very, very simple. We want to take this equation and we want to isolate x squared first, and then we want to take the square root at the end. All right. So how do we do it? Ready? So if you know how to solve an equation, you know how to solve these equations, these square root equations. There's nothing different about it. All right. Except for the fact that in the end, we take the square root to find our actual solutions. All right. So again, we want to solve for x, right? What we're going to do first is we're going to isolate x squared. So how? Well, first we're going to get rid of this minus 27 by adding it. That's what we did here. So add 27 to each side, right? Then we're going to divide by 3. We're going to divide by 3 to isolate x squared. All right, so normally we'd be done, right? We got x alone. But now the last step is we're going to take the square roots of 9. All right, we're going to take the square roots of 9. And there's a positive and negative square root. So positive 3 and negative 3 are our solutions here. Okay? So here it is. The solutions are x equals 3 and x equals negative 3. All right? Hopefully that makes sense. It shouldn't be too hard. It's just like solving equations. All right? So here's another example. If we want to solve this equation, here it is. X squared minus 10 equals negative 10. Hopefully you're thinking right now that we're going to add 10, right? We're going to add 10 to the other side to isolate x squared. You're going to end up with x squared equals 0. And again, we just talked about this. If we take the square root of 0, there's only one answer. There's only one solution. There's no such thing as negative 0, right? Now finally, the last example shows us that if we want to solve this, if we want to subtract 11, right? We want to subtract 11 we're going to end up with negative 5x squared equals 5. And we want to divide negative 5 now. But what happens is we end up with x squared equals negative 1. I just discussed the fact that we can't square a number, a real number, which you're going to learn later in other math classes that there are such thing as an imaginary number that where you could have a negative square root, but as of right now, we only know that when we square a number, it can't be negative, okay? It cannot be negative. So this equation doesn't have a solution, all right? When we end up with something squared equals a negative, there is no solution to that equation, all right? Simple as that, okay? So we're going to skip to the on your own problems. I'm going to have you guys pause your video at this time and give these a shot. When you get back, your answers will be up. Okay, so in number 1, we're simply dividing by negative 3, right? To get x squared equals 25. And then we're taking the square roots. When I say we're taking the square roots, that means the positive and negative answer. So that's where we get a positive 5 and a negative 5, right? Number 2, if we subtracted 12 from 10, we end up with a negative number. So x squared would equal negative 2. That's not possible, all right? So no solution. And then last here, we add 15, we get 0. We divide 4, we still get 0. And then we have x squared equals 0, and the square root of 0 is 0, okay? So there it is. All right, now moving on. Let's see if it says anything important. Nope. Moving on to something a little more difficult is solving like something where there's an expression, okay? Okay, so I'm going to show you an example of like where do we get this? Where do we get this x minus 1 squared in parentheses? All right, well, I'm going to show you an example of where we got that. If you guys were asked to do this, x squared plus 6x plus 9, right? And I said, hey, factor this trinomial. You'd go like this. You'd make your x. You'd say what multiplies to 9, what adds to 6? 3 and 3, right? 3 and 3. So instead of writing x plus 3 twice when factoring, we'd actually just go like this. X plus 3 squared, okay? That's essentially what this is. They've kind of already factored something, a polynomial, and they ended up with x minus 1 squared, just like we did here. But now it's set equal to 25, and they want us to solve this, okay? That's just a quick reference of like where does this come from? All right, now they want us to solve this thing. So here it is. In order to solve this, or something like this, an expression like this, I need what's in parentheses isolated, okay? Which it already is. It already is isolated. So what I'm going to do is I'm going to take the square root right away of 25. And remember, there's 2 of them, okay? So I'm gonna pop that up. So here it is. They just put a plus and a minus sign in front of the answer, all right? They don't actually write 2 equations out, but I'm gonna do that. I'm just gonna show you a different way you could look at this. They took the square root of 25 right away to get rid of this to the second power. That's how we get rid of a squared. We take the square root, we do the opposite. It's always inverse operation. So that's what they did. So here's another way we can look at this. This is really saying that x minus 1 could equal positive 5, or x minus 1 could equal negative 5. So there's another way, I'm just showing you another way you could write it out as 2 separate equations as opposed to this, what they did, all right? And then just solve these equations. It's as simple as that, right? So I'd add 1 here. I'd add 1 here and get x equals 6. And I'd add 1 over here, same thing. To get x equals negative 4. Okay, so this is just another way to look at it. Now again, I'm going to erase this. The book just takes the square roots and just writes it as plus and minus, right? So again, they add 1 to both sides. It's kind of confusing even to me how they kind of look at this, but they add 1 to both sides, and then it's basically 1 plus 5 and 1 minus 5 to get our answers, which are 6 and -4, which is what I essentially just showed you. Okay, but again, remember, another way to do this is just write 2 equations out. One that says x minus 1 equals positive 5, and one that says x minus 1 equals -5. Just solve them. All right. Now it shows you, what if we graphed it in a graphing calculator? Here we can check our solutions, but most of us don't have graphing calculators, so we're going to move on. All right. Let me show you an extra example here. All right. So I'm going to show you this myself. It doesn't give us our solutions on the computer. So again, here's what we're going to do. I have what's in parentheses isolated, right, to the second power. So what I'm going to do is I'm going to take my square root of 49. I'm going to take the square root on both sides, really. Why? Because it gets rid of the squared. Okay? So what this gives me is x minus 3 just gets rid of the squared on this side, right? Equals, I'm going to write 2 equations because that's just what I like to do personally. I'm going to write 2 equations. One that says x minus 3 equals the positive square root of 49, which is 7, and x minus 3 equals the negative square root of 49, which is -7. Okay, I'm going to solve them. Adding 3 to both sides gives me 10. Over here, adding 3, same concept, same way of solving, different answers. Adding 3 on this side gives me -4. Okay, so these down here are my solutions. All right, but that's essentially it. It's very, very simple. If you know how to solve regular equations, you're just isolating x or the expression that consists of x, and then you're taking square roots. All right, let's take a look at this. I think we kind of get the point. So what we'll do here is, again, I'm going to just pop these questions up, and I'm going to have you guys give them a shot. All right, and I'm going to give you a hint here. I'm going to give you a hint. Number 5, we have to get, again, what's inside the parentheses to the second power alone first before we take the square root. Okay, so like number 5, again, what we want to do is we want to try and figure out how do we get rid of this 4 from this side of the equation, and then we'll take the square roots and try and solve it. All right, so I want you guys to pause your video at this time. When you come back, answers will be up. Okay, so we are mainly focused on, let's mainly focus on number 4 and 5. All right, number 6 goes into something that we haven't talked about in a very, very long time, where they are just simplifying square roots, which, again, I don't really expect you to kind of know what's going on here. 4 and 5 is what I'm concerned with. If we could get the answers to numbers 4 and 5, we are good to go. All right, so I'm going to move forward here. I'm going to move forward here, and I'm going to skip to the mini assessment, which basically, guys, this wraps up right here. Everything you need to know. So hopefully, back up and go into here again. So hopefully these answers kind of make sense to you. All right, so if we were taking the square roots of 100, you get 2 answers, right? In number 2, if you subtract 10, you get a negative number. That doesn't make sense. Number 3, you add 7, you get 0. You divide 5, you still have 0. So there's only one solution. All right. Now number 4 is different. Number 4 is different. If you divide it by 2 from 72, you get 36, right? So what you want to do at that point is take the square roots of 36, which would be positive 6 and negative 6, and you'd set x plus 2 equal to those. All right, so x plus 2 equals positive 6, x plus 2 equals negative 6, and then you'd solve those two solutions. You solve those two equations, all right? So hopefully that makes sense. So what you guys are going to do at this time is just complete a couple problems on this lesson. Hopefully this made sense to you guys. If you have questions, as always, I will be in the discussion thread in Canvas. So if you have questions, please ask them. I will be in there live during your work time. So ask questions if you have them. Otherwise, hopefully this made sense to you. And good luck on your activity. It's just kind of practice, no benchmark, nothing like that. And then we'll move forward tomorrow. All right, I'll talk to you guys later.